Okay, so for this first problem, it says, determine the probability of selecting an ace or a 4. So what's going to make me happy is an ace or a 4. Okay? So we're doing happy over total. So what is my total going to be? 52. So now we've got to figure out how many are going to make me happy, an ace or a 4. So 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be, for the first one, it's going to be 8 over 52. Math enter, make it a decimal, make it a fraction. We all good? Yay? All right. Now, the next one's a little bit harder. I'm going to move this one down. The next one says, what is the probability of a picture card or a black card?
What is a picture?
A card with a picture on it.
Sorry.
Yeah, you're fine. A picture card, also known as a face card, or a black card. Okay, so if I look at, and it doesn't matter which one I do first, if I go to picture cards, do you agree that all of these are picture cards?
Yes.
So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 picture cards. Now, if I go to the black cards, all of these are the black cards. But I don't need to count those because that would be double dipping. I only need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's going to be 32 over 52. The main thing I want you to realize is don't double dip. You don't want to count the black face cards twice. So either you can say, let me count all the black cards and then add in these. Or let me count all the face cards and add in those, but you don't want to count those twice. No double dipping. Okay? A single die. Single die, remember, is 1, 2, 3, 4, 5, and 6. What's the probability of rolling a 2 or a 6? 2 out of 6. What's the probability of rolling a number greater than 4 or a number less than 2? Okay, a number greater than 4 would be those. Okay. A number less than 2
Is 1.
is that. So how many numbers make me happy? 3 out of the 6 numbers. So this one would be 1/3, this one would be 1/2. Good? All right, I'm going to give you a couple to try. First one says the probability of a jack or a club.
What is a club?
Okay. Yeah. Okay, we have diamonds, we have hearts, we have spades, and we have clubs.
Oh.
And then over here it says a card greater than 9, and they're in order. An ace is like a 1, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, or these are bigger than 10. Okay? And then, or a black card.
And those are black cards up here.
And these are the black cards. So those are your 2 examples. A jack or a club, a card greater than 9, or a black card. And give me a reduced fraction. I want to see them. A reduced fraction. reduced fractions.
Both of yours are correct.
So think about what makes me happy over total. How many cards make me happy and how many total cards are there? Perfect.
Just like me.
I know.
I need a profession in statistics when we finish this. You go work for the Census Bureau. I work for them and
Okay, for the first one, a jack or a club. So, I'm just gonna start with jacks. How many jacks do we have?
4.
4. 1, 2, 3, 4. So we have 4 jacks. Now, how many clubs do we have? Well, our clubs are all of these. But we can't count this one because we've already counted him. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because we have already counted that jack. So if I add those together, that is 16 out of 52. So the answer should have been reduced 4 over 13. That's what I'm looking for your first one. Yay? Now, for the second one, a card greater than 9. A card greater than 9 is going to be those. 4, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 cards that are greater than 9. Now, black cards are going to be all of those. But we're not going to count the ones we've already counted. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And if I add those together, 34 out of 52, 17 over 26. Feeling better about those? Okay. Now let's do a couple this one. I'll let you try this one. An odd number or a number greater than 4. Don't call it out. An odd number or a number greater than 4. So think of what makes me happy. An odd number or a number greater than 4. So my odd numbers are going to be here. My number greater than 4 are going to be there. So how many total numbers make me happy? 1, 2, 3, 4 numbers out of the 6 numbers make me happy, which is going to be 2/3. Even though the 5 makes me happy, it's okay, it just makes me happy. Yay? Alright, next page is just talking about what we just did. Alright, gonna let you try this one. I want the answer as a fraction. Reduced fraction. give it to me as a decimal. We'll do decimal this time. To me as a decimal. To me as a decimal in 3 places. Yes. Man, you cooking. That's it. All right, I see the word or. So we're summarizing how people died, and they're saying, was the driver of the car drunk or not? And was the person walking down the road drunk or not? Okay, so for this problem, it has the word and or, so we know we're doing shading. Pedestrian was drunk, so the person walking down the street was drunk. And the driver was also drunk. So you have a drunk driver with a drunk walker. Now, it has the word or. So what kind of shading are we doing? All shaded. So it's going to be 266 plus 59 plus 79 all over 985. So I think it was 404 over 985, which ended up being 410. Good? All right, let's try another one. Same chart. If 2 different pedestrians, 2 different walkers' deaths are randomly selected, find the probability that both of the walkers were walking drunk. Give it to me as a decimal. 3 places. 4 places. I have mine at 4 places. You done? Okay. You said what? Yeah, you're throwing yourself off. Yes, you're throwing yourself off. No, okay. we are looking for intoxicated, because this whole thing is talking about pedestrian deaths.
Okay.
This whole thing is talking about pedestrian deaths. So I wanna know, what's the probability that I get a drunk driver and another drunk driver? And I may have thrown you off when I said it.
Okay.
So drunk driver and drunk driver. So the whole chart is talking about how 985 people walking on the street died. So this whole thing is talking about how the people on the street died. So did people, the ham sandwich. Did the people die because the pedestrians, the people walking were drunk, and the people that hit them were drunk? Or were the people walking sober and the people hit them were drunk? Or was everybody drunk? Or was everybody sober? So of the 985 walkers on the street walkers, 59 of the street walkers were drunk when they died, and they were hit by a drunk person. 266 people that were walking were drunk, and they were hit by a sober person. 79 were sober walkers that were hit by a drunk person. And here, 581 were sober people that were hit by a sober person, like a little kid that was hit accidentally by somebody. Does that make sense? So, this is saying if I pick 2 streetwalkers that got killed, not streetwalkers as in hookers, but 2 people that were in the street that got killed, what is the probability that they both got killed by people that were driving and drinking? Okay? So we are just looking at the people that got killed by drunk drivers. So I am only looking at the drunk driver deaths, which is going to be the 59 and the 79, which is what, 138? So 138 of the people got killed by drunk drivers out of 985. So that first person got killed by a drunk driver. Now, what's the probability that the next person? 137 over 984. Because this one did not have the word and or. So 138 over 985 times 137 over 984. So y'all, if I turn that into a percent, there's not a big chance. There's only like a 2% chance that I'm going to get 2 people that were back-to-back killed by drunk drivers. Because if you look at it, most of the people that were killed by people who were not drunk driving. It was an accident. All right, let's look at another one. Let me see what I had up here. Let's change this to the word and. Same chart. So, this is saying the person walking in the street was drunk, but the person driving was not drunk. And because it has the word "and," we're gonna do the overlap. So this one's gonna be 260,
Your pen's strong.
I know, my pen is drunk, over 985, so let me do it with my calculator, that'll work. 266 over 985. 2700, or 27%. Good?
Yep.
All right, this is just explaining what we just did pretty. Now, I'm doing this one, and let me let you do the first one to see if you get screwed up on it. Same kind of problem. A decibel's fine. The directions really don't tell you anything, so I'm gonna move it up so you can see it. All right, this one says or. So or is gonna mean any shading. So we have given the drug, so that's gonna be the drug right there. And we have the placebo, which we know is the fake drug, which is right there. So what makes me happy is gonna be any shading, and then we have the total. So what do you think we're gonna put for the top number? 220. Okay? What are we gonna put for the bottom number? 300. And what I wanna make sure you realize is that the chart is really just this. That's the chart. Those extra numbers are the adding up for you. So the 65 and the 55 gives you the 120. The 42 and the 58 gives you the 100, and it's okay that my shadings are not overlapping because it says any shading. So we're taking the 120 and we're taking the 100 to give me the 220. And that 300 is really the sum of everything in the chart. Good? All right. They're going to get a little tricky. Okay, try this one. I want to see this one. Write it down.
Yeah.
That's perfect. That's perfect. I see your face. Which type it in again and let me see it. Type it in. Let me see what you put. That is the perfect answer. And I'll tell you why in just a minute. That is perfect. Perfect. Perfect.
No,
You're so close, but you're overthinking.
that's what I'm afraid of. Oh,
All right.
I know.
Yes.
Yeah,
Okay, let's talk about it.
duh.
This is an OR problem, which means any shading. So we have, later, improved, so that will be improved, and we have did not improve. So what makes me happy is either gonna be the 138 or the 162, and the total is gonna be the 300. So when you add that up, it's 300 over 300, and then I started getting that, oh, I did something wrong.
Yeah.
Because your answer's 1. Okay, so if I turn 1 into a percentage by whooping, do you agree that's 100%? Y'all, if I say, what's the probability that either you're gonna get better or you're not gonna get better?
You've covered all the bases.
If I say, what's the probability that either you're pregnant or you're not pregnant? What's the probability that either you're a girl or you're a boy? 100%. So the probability that you're either gonna get better or you're not gonna get better is 100%. Because either one of those is gonna happen. You with me? All right, let's look at another one. Doing a lot of fours. Let's do an 8. Let me do that one because I think that one has some. Let's do this one and then we'll do an and. The probability that they were either given the drug